In this video, we make comparisons between our method and event VFI baselines on 4 benchmark datasets. We start from our real capture dataset. The first scene is a fast-spinning basketball. TimeLens cannot estimate complex motions of the ball, thus lead to severe color artifacts. CBMNet performs slight better, but still with fraction and distortion in the ball and hands. With correct optical flow, our solution interpolate balls stably. The second scene is for large nonlinear body movement. Due to invalid motion estimation, TimeLens results are flickering around balls, hands, and clothes. CBMNet works better around cloth region, but still hard to solve hands and balls. Our method produce best interpolation with least artifacts in balls and BOTUS. We then evaluate on another real dataset, BSERGB. In the first case, we need to interpolate for rotating balls and body with non-rigid motions. Let us focus on regions inside yellow boxes. When we switch interpolation results with TimeLens and CBMNet, it is easy to find that our result is clearer than baseline methods and produces less distortion and ghosting even for small objects like fingers. In this case, we view a rotating man with large occlusion regions. Please focus on regions inside the yellow box. As we could find, our method interpolate with less color distortion and more details, while TimeLens and CBMNet produce color distortions and blurry interpolation results. We then move to synthetic dataset. Here are detailed images with large camera motion. TimeLens cannot estimate flow from dense events, thus lead to inconsistent interpolations. CBMNet cannot predict motion with events as well, introduce flickering to rich textures like plants and house. Different from TimeLens and CBMNet, our method interpolates stably with much less distortion and inconsistency. Here is another example, with large camera motion and rich textures. Limit by the two-segment flow formulation, TimeLens cannot accurately predict motion, thus lead to objects fraction and distortion. Similar to TimeLens, CBMNet is also limited at estimating motions from events, and interpolate with flickering car and distortions. Our algorithm correctly estimates motion, thus more consistently interpolate. In GoPro dataset, we will first test with a girl fast pass from left to right. Due to rapid motion and occlusions, TimeLens adopts a ghosting strategy to fuse the girl, thus lead to flickering. Same with TimeLens, CBMNet also cannot handle such motion and produce invalid results. Consistent with previous results, our method stably interpolates with less artifacts. Here, we will see thin parapets move. TimeLens is not able to predict motion for the parapets consistently, thus lead to ghosting and flickering interpolation. CBMNet has the same performance to TimeLens, parapets distort due to occlusion and inaccurate motion estimation. Consistent with previous results, our algorithm is able to interpolate to the parapets with less degradation. We compare methods on our HQ EVFI dataset here. Our TXL net is the fastest and most lightweight net with competitive results to event VFI methods, while TXL net plus outperform all baselines. Comparisons show the effectiveness and efficiency of our algorithms.